This week, chapter 6 is all about loops. Can anyone tell me what a loop is before we go into this too much? Elijah?
It's a thing that goes around and basically goes around and comes back to the same place.
Okay. So in code, it's something that goes around and comes back to the same place. Bill, you were going to raise your hand as well.
I was going to say a process.
Repeating process, exactly. One of the things, I can't remember in the textbook through Cengage whether we're going to address it this week, but we also have an idea called recursion. And you can create recursive methods that call itself until it reaches a certain gateway logic, and then it exits the call of itself. So recursion is just one method that calls itself inside the method. And you continue that call doing a particular operation until you get to a point where you're saying, okay, I'm not going to do this call anymore, and I exit out of that program. The typical loops that we're thinking about, we'll be using in Java, these consist of the while loop, the for loop, and the for each loop. Okay, the while loop, the for loop, and the for each loop. So what I want you to do, actually back up. Let's talk about things that are happening real quick for this week. I'm going to give you information on Project 2, which will be March 21 through the 24th. March 21, 2024. This project is going to be your first opportunity to create a text-based game. Okay? And we're gonna walk through creating some of it, and then you're going to implement the rest of those features. Okay? A text-based game. You're going to use math.random to add a little bit of uniqueness into the game. You can also use ASCII art. Have you guys used ASCII art before?
No.
There are some sites that have ASCII art where you can create actual artwork with ASCII code. Okay? It's all text-based. So we're going to jump into that a little bit today. We'll do more of that next week. Today, of course, you have 3 assignments. There's flashcards. There are the slides that I want you to look through. And, of course, there is a quiz over Chapter 6 today. Tomorrow, I'm going to release the midterm exam part 1. This is going to cover chapters 1 through 5. Midterm exam part 1. You'll have about a week to work on it. You can take it as many times as you like. Okay? That's important, as many times as you like. And it's open book, open notes. Okay? The idea behind these exams is I want you to absorb the content. Okay? That's really what it's about. Not as much as you remembering everything. If you decide to go for your Java certification, then you have to know everything. You have to remember everything, including how memory management is done with a Java program. So it's very detailed. But since this is your first foray into programming, I want you to get as familiar with the topics, the syntax as possible. So your exams are open book, open notes. Bill?
How many questions and if there's a time limit on it?
I think there's going to be like 100 questions.
No time limit.
No time limit. Okay? You take it as many times as you like. Okay? So don't wait until 10 o'clock on the last day of its availability to try to take it, because the time limit is the last day, okay, at midnight. All right? None of y'all would never do that, right?
Never.
Okay. Hot dog. All right, so we're going to move on here. You got your reading, flashcards, PowerPoint, okay? This is the programming assignment. So you're going to create a class called Player Health. Okay, Player Health. And it includes 3 overloaded calculate hit point methods. Everyone knows what an overloaded method is, right? You kind of got some taste of overloading again with constructors this last week. So an overloaded calculate hit point method. This is an online fantasy text-based game, okay? The three overloaded methods will determine the impact cost on overall life of an individual player when they're struck by a sword, a spell, or by hand. Okay? So you can imagine what the most basic would be. It's the Russian hand slap, right? You guys watch those contests?
Oh, yeah.
How many would like to do that? No? Okay, me neither. Because it looks like they always hit them in the ear.
Has anybody heard of the slapping game where
Yeah, I'm not. Yeah. All right, so it's text-based simulation using the command line parameters. So each parameter passed in must be of type integer. Okay, so 1 will be a hand, 2 will be sword, 3 will be a spell. Right? The value displayed must be a type decimal or double or float, meaning there's a percentage on this person's life. You're going to try to see if this person's life is going to end based on what they go against. Okay? When you calculate the hit points, you'll have an int that says it's a hand strike. All right? And this receives a single parameter. It represents the hit point cost of a hand strike. Hand strikes will have one parameter of the point level of the hand strike and be multiplied by 2% damage against overall health. This means that a hand strike will be added to 2% of the total life to determine the damage, right? You guys can read, right? So here's a sample algorithm. Here's your total health. Hand strike plus 0.2% times the total health minus the total health. That's the sample algorithm. All right, so if you're going to calculate points, the next overloaded method will be a hand strike and a sword strike. Okay? This receives two parameters. It represents the hit point value of one sword strike. Parameter 1 is the level of the hand. Parameter 2 is the level of the sword. Add parameters 1 and 2 together and multiply against 2% of the total ratio to display the, okay? Very simple calculations here. All right, the third overloaded method. Hand strike, spell type, and spell power. Hand strikey. I misspelled that. Hand strikey. All right. Yeah, where was Grammarly? I don't know. All right. Hand strikey, spell type, and spell power. It receives three parameters. This will represent the hit cost of one spell strike. Parameter 1 is the point level of the hand. Parameter 2 is the type of spell. Okay? And parameter 3 is the level of the spell. Be creative here. You could have a different coded spells. You might make each spell a different point level, right? And the third parameter will contain the additional overload of its power. So parameter 1, parameter 2, parameter 3, together 2%. So you could have something like the spell is freeze. They're frozen. Or it's dragon's breath. Or, you know, whatever you can think of. It's up to you.
power, word, kill?
Whatever, it's up to you, okay? You just have to follow the implementation of these methods, okay? Now, your creativity here is important. Be creative. Go out and use some ASCII art to display back, you know, like if it's a hand strike or a spell, create some, you know, there's really cool ASCII art you can implement, okay?
Can we use like somebody else's ASCII art, not our own?
Yeah. There's what I'm saying, Elijah, is there's places online that'll actually generate ASCII art for you. So when you run this program, you don't want to run it just in the bottom of your IntelliJ. You want to open up a nice big command window and run it so that you can show the full screen, okay? Now, it isn't listed here, but it, you guys should be able to do like a screen video capture. You guys have that ability on your Windows machines?
What character width are you recommending?
Character width?
Yes, like the number of characters.
It's up to you. It's up to you. Just make sure it fits on your screen or my screen. Okay? Yeah.
When the game is finished, how are they gonna how do I let them play my game if I ever finish the game?
So it's a one person game. Okay? You're playing against the computer, and you just it's code. So if you wanted to share your game with someone, you could just share the code. Okay? All right. So here's your final requirements. I've got some different things that you could use. Like I have a long sword, a kung fu punch, an iron fist punch, spell tornado, spell lightning, right? These are all constants that I created. Be creative, okay? But just follow the format in the code that makes it proper with your constants the way you have it. All right, this is going to be due March 28th. March 28th. Okay? So you got some time. And this week should give you some time as well. Yes?
Can we use Unity?
No.
What happens
No,
if
this is a Java. Guys, to be clear, this is a Java program. Okay? It is text-based. All you're going to deliver is one text file, one Java class. That's all you're going to deliver. Okay? All right? Okay, so let's go ahead and open up IntelliJ, and then we're going to start running through some of the assignments this week. But we're going to introduce first the types of loops. Okay? So create a new new project. I'm going to call it Going Loopy. I encourage you to follow along and do this with me. Okay? The more you program, the more you do this, the more fluent you become in the language. You get used to the syntax. You get used to the type of language features. Okay? When you guys are there, let me know. Okay? Everyone got this point? Okay. All right, so we have our sample project set up. Go into your source directory now. Choose Java class, and we're just going to call it Going Loopy. Okay? Everyone with me? Okay. We're going to set up a standard class, so just make sure you have PSVM, public static void main method. Okay. And let's set up our most basic type of loop. Okay. Your most basic type of loop is the while loop. Your while loop is going to include while and 2 parentheses. Okay. My mind just went blank here. Okay. You know, I do this all the time, but I always forget. This is like a method. Okay, I apologize. Your inside your method is the Boolean condition. All right. So what type of things would evaluate for a Boolean condition? The most basic would be to do something like that. And if I do system out print line, hi, how are you? And I run this program, what do you think it's going to print?
Hi, how are you? Wait, no. Hi, how are you? Not the first time.
Wait, print line is not working for me.
Okay.
There's nothing because there's nothing to define that as cookie.
Well, you notice the program is still running. because I never exit the condition. Okay? So if you get this problem, just click stop going loopy. Okay? So your most basic type of while loop, it has to evaluate some condition. Typically, we would do something like this. We would say int num or int count equals 5. Okay? Or int count, let's say int count is 1. And then inside of this, I would say while count is less than 6. Now, how many times will this print out then? Yeah, can everyone tell me why it will infinitely print out?
Because 1 is always going to be less than 6, and there's nothing determining that number changing.
Correct. So typically we want to determine then where we're going to do our incrementing. So I could do an increment before, and this is very important. If I do my increment before, I'm going to, well, it doesn't matter here, but wherever you use your count, say in your program, it's going to display that number, right? So here it makes it pretty straightforward. My first number is 1, while count is less than 6, count increment. Hi, how are you? What's the number? 2. Let's check it out. It starts at 2 because I had my incrementer at this place. If I move my incrementer down below, now we're going to see that it actually goes 1 through 5. Oh. All right, but let's mess with your brains a little bit. Now what's going to happen? Interesting, right? Interesting. So we're incrementing, but we're kind of manipulating the string concatenation principle here. Usually, if you do something like count plus 1, now what do you think is going to happen? You're like, why is it 11, right? Yeah, because remember when you do this, you're doing string concatenation. Okay? And because this now has become a string, this is going to be added to the string. But if you do this, we get around that weird behavior. Okay? So always remember where you use your concatenation, where it's happening. All right, so this is our first principle, our first type of loop. While count is less than 6. We have a value that it's set to, and it happens. But let's go ahead and set this back to true, and let's do something different. We're going to say if count is less than, let's say, if count is greater than or equal to 6. Notice I'm using those curly brackets. I got an email from someone saying the curly brackets messed you up. They can if you don't forget to put them, if you forget to put them in there. Now I've moved my gateway operation to exit the loop inside of this method. Let's run it and see what happens. Right? So if we debug this, I'm going to put a breakpoint here. And I'm going to debug my application now. We'll see that wrong place for the breakpoint. Let's do it there. Let's debug it again. All right, so we see that so far, here's the arguments, which is this variable here. And we can see that count is already set to 2 because it's incremented what was 1, right? And we're asking the question, if count is greater than or equal to 6, then break. Is it? No. So we go back up, and now we hit that again. Count is now 3, count is 4, count is 5, count is 6. I meet the criteria, then I hit the break point. I hit the break statement. And that forces me out of the loop, and I'm done. So there's many ways that you can exit from a while loop, right? Another variation of the while loop is the do while. Did I do that right? Let's see. Do while. Where is that at? Dagnabbit. Yeah. Forgetting the curly bracket. All right. In this instance, I'm saying do the operation first while the condition is still true. Okay? So there's variations of this that you can apply with a while or do while. Really, all a do while is it takes a code block, and the code block is what's in between these two curly brackets. Okay? In Java programming, you can separate code into a static block, and you can have it do stuff. Okay? So this code sets in a static block, and really all we're doing with all of our loops is we're applying the logic on those static blocks. So if you run this code, of course, what you're going to see is it runs do stuff, and then it does what's in the static block in the rest of the next code block. Okay? So this is called a static block. And a do while is using a static block and it's putting logic on it. Hey, do this static block so many times. Okay? All right, any questions so far? All right, so let's take this a different direction. Let's delete all that. Let's go with a new type of loop, and this is called the for loop. So in the for loop, you have 3 parameters that you have to define. I could use my parameters up here. I'm going to comment this out for right now. But I can also declare what that parameter is going to be inside the for loop. And now that parameter is used only for, it's tied to that for loop. So the first section of my for loop is defining the parameter. The next one would be declare the condition. This is the same as the while loop. While 0 is less than 10. And then I set up my incrementing fashion, my incrementing number. So in this instance, I'm going to say count plus plus. You guys follow? Now there's 2 ways we could do the incrementer. This is called a post increment, or we could do a pre-increment. Can't do both at the same time though. With the pre-increment, it changes how the value is displayed. So with a pre-increment, if I displayed this number on its own in a pre-increment, it would automatically say 2 instead of the number. Okay? So pay attention to where you use the incrementer in this operation. All right, so in this scenario, I have my count, and I've set up the amount of times it's going to perform the operation. And so I could do something like this, system out print line, calculating plus, and I'm going to put it in parentheses because I want this to, I want it to be separate, not string concatenate before the operation occurs. So I'm going to say count times count. And if we run this, we'll see this. Yeah.
Yep.
All right. A lot of numbers. And it's all over the place on this value. So let's, when we do this operation like this, what we're doing is we're, well, we're going to run out of memory is what we're going to do. Let's do it like this first. We'll do int num1, and then I'll do num over here. Now let's run it. What are we doing wrong? Yeah. Let's do this. Num equals count times count num. We're changing the value of it somehow here. Int count. Make sure I'm doing this right. Because you know Mr. Rogers makes mistakes. All right. We got ourselves a weird scenario. So what we're going to do is that. And then num equals num times count.
Mr. Rogers, could it be with the second statement? The for loop? The for statement?
Which part?
The second one. It's saying right now 0 less than 10.
Aha! So, let's, hey, this is a great teachable moment here, okay? How many of you were working on your assignments and you're just like, I don't get it, why is it not working? And then you started looking at it, you go, oh, there's just this one little, yeah.
Sometimes I also forget I send a comment.
It happens to me all the time, even till today, okay? All right, so let's review again. We'll just run it again. Okay, so now we get it. All right?
So it does not show the 10 times 10.
Yeah. So we're assigning count. We could just, let's go back and just do this again real quick. Count times count. There we go. There we go. Same effect. All right. Let's talk about, though, the condition we ran into a moment ago. If you let it run in those conditions, you will eventually hit what's called a Stack Overflow. Okay? And there's even a website dedicated to software developers called that. Has anyone found it yet? Yeah, because you're like, I use that, Mr. Rogers. Yeah. So you have to think about memory management at this point, how far you're going to go with the variables and what your gate is going to be, okay? You can also do some other interesting things here, okay? I'm going to take these out just for a second. You can also do a decrementing. So say I have 10, and I want my count to be my count is less than or equal to 0. All right, you guys you realize what it's doing now, right? Yeah, it's just minusing. And so if we display the count, you see it just does the countdown. Yeah, 10, 9, 8, 7, 6, right? There's other things you could do here. You can actually take out this portion. You notice the code still runs. You can put your count down here. Now you still have to have these separations. Okay? Right? In fact, I believe you can even move the second part out. You can put this down here. But the separations have to remain. Semicolon. Okay? What is this complaining of? Not a statement. Yeah, because we have to set up the logic. So we'd have to say if count is, right? There you go. If count is less than or equal to 0. It's going to break. Now we've missed something here, but anyways. So this is your first type, or your first type of for loop. Let's take this another direction. What is one of the most common ways that we use these for loops is with iterating through something called an array. Have you guys discussed arrays yet in Cengage? No? All right. So let's create a simple string array. Okay? And the syntax for creating a string array is string bracket. We'll give it names equals new string, and then we have to specify the size of that array. Now here's the thing, all arrays begin index number 1 of an array.
Yeah, something's wrong with my thing.
Okay, index number 1 of an array is the 0 identifier, 0 placement. Okay, so if we're looking at populating this array, we would do something like this. We'd say names equals, what's your first name again? Akira, right? But the way we would do that is we would assign Akira a placement. So you have to say where his name is going to be in that array. And we'd specify number 4. We could do names 3, Bill, names 0,
Chris, preferred.
John.
we'll just do that. All right. So let's think about how would we read from our names array. Well, we would do it by the same methodology. We'd pass in the variable that we want to access it by. All right. So in this instance, if nothing is present, you kind of get this strange index out of bounds situation. And really, because we have to start from 9 and not from 10. Now think about that. Why do we start from 9 and not 10? Because the bottom of the array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you specify something outside of the array, you're always going to get the array index out of bounds exception. And it's very self-explanatory. You'll say index 10 out of bounds, right? You guys ever played hide and go seek? Sorry, you're out of bounds. You can't go over there. You're giving me an out of bounds exception, right? All right, so it's an out of bounds. All right, so if we run it again,
What is every single thing you have to get one?
all right. So now we're going to get nulls. And let's figure out why. We'll go to debug. Okay. And the count is at 9. And when the count is at 9, here's why. We forgot to put our decrementer, right? All right, so let's do this again. We'll run it. And you can see that for the items there was nothing, it prints out null. Null is a special word, special keyword in Java. It means that nothing is assigned. There's nothing there. It's not 0. It means no assignment. Okay? 0 is an assigned value. When there's nothing there, there's not even 0 there. Okay? That's how it works in the programming world. And we recognize that by the keyword null. So in this instance, we're iterating through it starting at 9, and we can see nothing is there at position 9, nothing is there at position 8, 7, 6, 5, 4, there's Akira. 3, there's Bill. Nothing at 2, nothing at 1, and then at position 0, there's Chris. Okay? All right. These are some of our for loops. There is another for loop, which we'll go ahead and introduce you to. I'm going to delete this out right now. Okay? Y'all ready for this? Bam, it's gone. All right. We're going to change our length of our array to 4, and let's change it to 5. Change it to 5. We got 4, 3. Let's go ahead and say names 2. Give me a name.
Jericho. Yes, Jericho.
Jericho. Jordan.
Names.
Michael Jackson. Michael
Just
Jackson.
so you know, I have an H.
No, just leave it like that.
Right here?
Yeah, that's good. Thank you.
Or right there?
No,
All right.
Jeremiah, actually.
All right. So let's talk about a for each. A for each loop is a special type of loop that you can only use when you have an array. Okay? A for each is something you can only use when you have an array. And the way the for each is the first parameter of your for each loop is going to be the array type. So here I have an array of names. What is the type of array? String. And the best way to do this is if the array, best practice is to name the array plural. So here it's plural, right? It's names. So best practice for when something is not plural, you remove the S, right? It's the same way when you're identifying the identifier when you're using a for each loop. So it'll be the type that aligns to the array, and the variable name is going to be Best practice is to be the singular of whatever the plural is for that array. The next item you add is the array itself. Okay? And if we do a system out print line, we would do system out print line name. All right. I don't bet, because I don't have any money on me. But who would like to say that it begins at Akira?
Because of what?
Which direction do you think this array begins at?
From 0.
From 0. I would say you're correct.
X credit?
Because it begins with the natural identifier of the ordering. Okay? All right. So those cover our basic types of arrays. All right, so let's take a switch real quick here. Go back to our assignments, and let's look at the first assignment. So our first assignment is called count by fives and count by anything. All right, so count by fives. I'm going to go back. I'm going to create a new class, count by fives. Hit enter. We got our class. All right. Write an application called count by fives that includes final constants named start and stop that are set to 5 and 500. All right. Final constants. So we're going to do final let's see. Let me back up. Public, final, static, public, there we go. Final static, what was the first one called? Start. And this is going to be an int, so we'll say public static final int, start, and this one is 5, public, final, static, int, stop, and this one is 500. Okay, PSVN, public static final, is our main method. All right, the application counts by 5 from 5 through 500 inclusive, and it starts a new line after every multiple of 50. Okay. So we got to think how to do that, right? So, for int count equals 0, count is less than or equal to stop, count is plus let's see, how do we say that? Let's just do plus plus for a second. Okay? All right. Application counts by 5 through 500 inclusive. So, we wanted to print something like this down here, but this is a separate program. This is count by anything. We want it to counts by 5 through 500 inclusive and starts the new line after every multiple of 50. So we're going to have to use some logic here, right? Some branches. And we're going to say if counts by 5 starts a new line after every multiple of 50. So let's do this. Int num equals 0. How would we do this? How would we do this? So if count, yeah, so we're going to say, I'm going to take this part out down here, say count equals count plus start. And num equals count. If num modulus 50 okay, y'all follow what I'm doing so far, right? System out print line num. System out print line num. So count equals count plus start. Let's do it this way. Take out the print line, just make it a print. Then we're going to say, you guys been introduced to the new line character? Yeah. All right. So I don't know if this is going to work or not. This is going to be fun. Let's run it and see if see what happens. Does what it's supposed to do, right?
It shows 505.
Yeah. So that's because,
It's greater than R because it's equal to stop.
yeah, I think it's because I'm using the, I think it's because I'm using this extra variable here. So let's just take,
You can take out the
which one?
this one, the equal sign.
Okay. There we go. Good job, Akira. All right, so that is your first, that is the first class, right? All right, I am recording, so you should be able to, okay? All right, so this is count by fives. You guys understand the logic, how we got there, right? We're only printing out once the number reaches the specified value. And we're starting by 5, but it's called count by 5. So we're just adding 5 to it every time we iterate through. Okay? Okay?
So Rogers, do we need to put the line 9?
I don't think we do. I think this may be extra. Let's test it. I think we can just get away with doing doing that. Let's test it and see.
Even in the if statement.
Yeah, good catch. Good catch. It went by so fast. Yeah, we don't even need line 9. Okay, you can take out that line. So you don't need line 6 or line 9. Sometimes it helps to break the numbers into extra steps, right? If that helps you, that's fine. I'm not going to count it off on you. But if you're thinking about making your code concise and to use less memory, then this would be the best way. All right. So the next step in this is to do a count by anything. Count by anything. So let's create a new class. Count by anything. And we're going to take the code we have for count by 5. We're pretty much just going to copy from line 2 all the way to line 16. Okay? We're copying the stuff in between the two major curly brackets and just paste it in. If you get an error down here, it means probably you copied too many curly brackets. Okay? All right. So in the logic for count by anything, the user enters a value to count by. Start each line, new line, after 10 values. All right, so we're going to first of all enter a number to count by. I'm just going to copy that text real quick. And I'm going to type SOUT. Okay. Taking out the print line, only using print. Okay. After that, we're going to use a scanner. Call it input equals new scanner. System.in. Okay. And input is going to be next int. Int user num. All right. And we need to add that to our count by sequence. So if the idea is we're going to count by 7, then it's 7, 14, 21, 28, right? So we're not going to use the start sequence anymore. We'll take that out. And we're going to use the user num. Okay? Does it make sense so far? And start each new line after 10 values have been displayed. So we're going to come over here and change this 50 to 10. And I think that's all we need. We don't need, it still goes up to 500. So we're still going to keep the stop. But we don't need the start anymore. Okay, does this make sense to everyone?
So I just have a question for
Yeah.
our num integrator. I don't see what it's defined as, since we're still using it at the bottom. Oh, never mind. It's count.
So we replaced the start, we replaced it with the user num, user input. Okay. All right. So let's test it. Enter a number. How about 33? I don't think this will work
It will if you move it.
because
It's not divisible by 50.
it's not divisible by 10. But anyways, we'll just, there you go. Well, it does finally find the number divisible by 10, and then it jumps to the new line. But it overprints because the count. All right, so let's do it with something below 10. We'll do 7 just to test it. All right, so we're at 504. So what in our logic is still allowing us to print if count is less than stop.
What is the stop? Is this the 500?
Yeah. It's because this calculation is happening outside of the for loop. So there's a couple of ways you could solve it. We could take this and put it up here, but now we have to declare count equals 0 and do that. Or we could just do this. By the way, in IntelliJ, no, we have to declare it. In IntelliJ, you can go down here to, where is it at? Factor, let's see. Code, there it is. Reformat code, and it'll push everything inside. All right, so now if we run it, and I put in 7. Oh, that's no good. What do we miss? Because we're always setting it to 0. So we can do this, I believe. There, we could do that. No, that doesn't work either.
That's an ASCII art.
It does kind of look like ASCII art, doesn't it?
Good wallpaper. From the maybe
Yeah.
Commodore.
Brings good luck in.
Yeah, it's a good Commodore wallpaper.
All right, so that logic doesn't work. So what we could do, we could just put down here a separate if count is less than 500. Yeah, and that forces it. Okay.
Where can I find the video for this?
It'll be on YouTube. Be on YouTube. All right, so that is assignment 1. Let's go ahead and take a look at assignment 2. Assignment 2 is even entry loop. Even entry loop. Okay. Assignment 3 is in between program. And then that's it. So let's go ahead and do even entry loop real quick. Source, new, Java class, even entry loop. Okay. Write an application that asks the user to type in an even number or the sentinel value. All right. In Cengage, we have this idea of a sentinel value is something that we use to exit a program. And there are different sentinel values that are available. For example, on a Mac, or a Linux box, you can say ps-ef pipe grep Java, and I can actually see a Java process that's running. And if I wanted to kill it, I would use kill-9. And in some ways, the -9 operates as a sentinel value that says, if you see this number associated to the PITM, kill it. Now, if I do this, I think it's going to actually shut down IntelliJ. Oh, no. Yeah, because, here we go, ps-ef pipe grep. There it is. And so I could identify this and kill-9, that number, and it killed a part of the background process for this. Okay? All right. Because I did that, I may have messed myself up. But let's go ahead and go back and look at our logic. The idea of a sentinel value is something that you specify that you don't think anyone else is going to enter, that you know if you enter it, it's going to kill the program. You could call it an Easter egg value. It's something special, right? Something that usually the users are not going to enter. Unless you tell them, hey, enter this number to quit, right? So enter a number, ask them to enter a number, or the sentinel value to stop. All right, so if we think about it then, we're going to do something like this, PSVM, while true, don't put your scanner inside of the while loop. Y'all know why that would be a bad idea?
Because we only work through that and not the rest of the code.
True, but you're also creating a new object every time. Yeah. It'll potentially use more memory doing that.
So then it becomes a game of chicken with your RAM.
Yep. All right, so system out print line. I keep hitting the wrong thing. Enter an even number or 999 to quit. So we'll paste that in there. I'm going to take out my print line because I want the user to enter it on the same line number as what I have. And I'm going to say int number equals 0. I'm creating that variable outside of the loop because I don't want to create new objects in a loop. That's just inherently bad practice. And I'm going to say input next int. And if number is equivalent to 999, break. Else we have two statements here. Good job, and this is not an even number, right? Good job and not an even number. All right, so else, let's do an else if. Actually, let's do this. Because we want to separate our logic of what's happening. I want my sentinel value to be executed first and to quit the program instead of tying it to other conditions. Okay? So now let's take the number, say Boolean flag equals number All right. Everyone understand what I've done so far? We can make our Boolean flag a little bit more explainable. We could say is even. And we'd say if is even, system out print line, great job. And then down here, I'm going to copy this thing. I'm going to say system out print line, number plus is not an even number. So let's analyze the code for a moment before we run it.
Can we directly put the number modules
You can. You can. It would make the code more concise, but there is a balance you always want to bring when you're coding to think about what is readable and what is more concise, right? Making things concise would be like saying instead of int number, I would say int x. But what does that really mean? It's concise, but is it readable? So you want to think about a balance between readability and conciseness. This is important as a developer. You will write code, and even if you don't ever pass it off to somebody else, you're going to forget what you wrote. It could be 6 months, it could be a month from now, it could be 5 years from now, and your boss would say, hey, I need you to modify this logic to do this instead. And you open up your code, you think, oh, it's so concise, but what does this do? Because you haven't named your variables in a way that make it more readable. So always try to balance it, right? Okay, let's run it and see what happens.
Can you just hold on it for a bit?
All right, so enter a number to count by, let's say 2. Oh, hang on. I'm executing the wrong code. Let's do this again. Run the event. There we go. Enter an even number or 999 to quit. So let's enter 2. Good job. Enter an even number or something to quit. How about 550? Great job. Right? Or 999 to quit. And it exits. Okay? Any questions so far? All right. We've got about 7 minutes left to class. I'm not going to do the last assignment for you. I am going to, though, jump into looking at Project 2 and talking about its code base for a moment. Okay? So, I'm going to create another file. Call it Java class. I think it's called player health. Guys, all of this is recorded, so if you get lost or you're not able to keep up, I will post this here shortly, okay? Let's go back to our instructions for the project. We have 3 overloaded methods, right? Calculate hit points. So let's go ahead and do that. Public, static, void, calculate hit points. The first one is a hand strike. Okay. So we're going to start with an int here, and this is going to be total health equals 100. The first method let's take out the static. I'm sorry. Here we go. There, I got to follow my own business requirements here. All right, so double total health equals 100. Okay. And this is our first method. What's the next method? Next method is calculate hit points with hand strike and sword strike. So we'll say public void, right? The algorithm is already published for you. So it's not hard. You just paste it in, right? Hand strikey. There we go. We'll fix that. And we got a third one. Fix the misspelling of my variable there. Okay. And then I'm just going to go back to the code base, copy the third algorithm. Okay. There you go. All right, so those are the three overloaded methods. Pretty straightforward. Okay. I'm going to go back now and capture some of this code. Kung Fu Punch, Iron Fist Punch, Spell Tornado. What's another spell we could create? What's that? I can't hear. What did you say? Fireball? Fireball. Okay. All right. Instant kill.
Oh yeah.
I can't spell.
One damage. You're joking.
Oh, there was a good one.
Yes.
We need that.
Emotional damage.
Goddamn.
Ouch.
Animation's gonna be.
All right, you guys can come up with whatever you want, okay? So you just create a list of the different types of things. Now, it's up to you. You can store these in an array, okay? You could hard code these. It's all up to you how you want to do it, okay? All right, so we're thinking about the implementation of this. Remember to avoid magic numbers. So we want to do something like this. Life cost is that, right? Well, where do I put life cost? Right there. Because you avoid the magic numbers. 2.02 is not a magic number. You guys know that song? Never mind. No one knows that song, The Magic Number? Akira, do you know what it is? 3. 3 is the magic number.
Is that coming?
It's like, huh? What? There you go, man. See? PBS Kids.
That guy's 6 characters.
Yeah. Yeah. All right. But anyways, in coding, we avoid magic numbers. And that just means hard coding a number in. So replace it with the appropriate value. Okay? All right. So we've got all these values. So now we need to public, static, void, main method, right? We have to implement player health. Okay, and then we go about it. So this is the part that it adds creativity. Think about creating a loop. That's going to loop through this until you reach the criteria. Like maybe you got to loop through it 5 times. Maybe they got to go through. You determine it. Maybe it's a random set. Maybe it's a random set of so many hand strikes or sword strikes or spells. And if they make it through all 3 a random number of times, then they made it. Okay? Yep.
Do we have like one play controls? Like instead of like attacking, do like how to say this, like a step? Like a how to say it's like Pokemon.
Yeah. Yeah. It's up to you. I want you to have fun with developing this, okay? But I want to see your creativity in making it interactive. And you already can use the scanner, right? It's text-based. So you're using the scanner, you're receiving input, you're directing them, lay it out. If your logic gets too big, create a separate function so that you kind of make things reusable. Okay? All right? It is 4:57. I'm overdue, and Mr. Will Malley is going to be coming in here any second. That's it for today.